Robot in 3 days for first tech challenge game, Rover Ruckus for 2018.
So this, all right, okay, I get you. You get this. No. Yeah, this sure.
Right, there we go. No, we haven't.
Many of us Robot in 3 days 1.0 team realized that we were spread thin this year because we were helping support and on the planning committee for the Kennedy Space Center kickoff event. So we decided to help jump on board with the Florida Polytechnic Alumni Club because they have built really great Robot in 3 days robots in the past. So we decided, why don't we just come here the day after kickoff and build our robot right next to theirs.
So initially, we started with the four-wheel drive, and that got us over the crater easy. However, when we installed the center intake, that caused problems whenever we went over the crater. So what we did is we switched to a six-wheel drive. So the best solution that we came up with was to raise the center wheel so it didn't get stuck in going over the crater. Going towards the crater straight, there was no problem, but going at an angle, that's where we experienced some difficulties. But with some driver practice, I'm sure we'll get over it.
We are Purple Fire Robotics Club here at Florida Polytechnic University. We're one of the only clubs on campus to compete at a national level, bring home awards, and represent our school. We're also the mentors for Team Rise, our local First Tech Challenge team. We invited everyone out on campus to try to get as many people as we could to introduce them to the world of FIRST. We hope to use this as a recruitment event to get new volunteers and coaches for FIRST in the future.
We took out our competitive robot from last year and learned that it could play Rover Ruckus with very little modification. It was fun to play and all, but we quickly realized we needed to get to work.
We're using omnidirectional wheels, so it's easier for the bot to turn because the turning radius is basically 0. It can just turn on the spot without any issues. It's easier to get over the game object and get over the obstacle to get into the different zones.
We decided to do a flicker shooter as well. So we took some 6-inch long pieces of Lexan and with a little bit of taper in that finger. And it spins around at a relatively low RPM, and there's a bar that causes the Lexan to fold back and flick forward.
When dealing with the idea of intaking the minerals, we came up with the idea of using sprockets surrounded by rubber bands. Now, initially, because of our raised chassis, we were unsure of where to put it, but we decided to put it in the center so that as we drive over things, we can simply just take them in.
So one cheer, one cheer. Oh, that's good. That works really well. So whatever the diagonal is, that's it.
It initially worked so well that our initial design for scoring them was to have a single axis arm with just another of the same roller gripper on the end of that arm.
Deploying is a really fun and cool part of this year's game. Our initial design was using a servo with a latch that we attached to last year's robot to test it out.
Beautiful. As long as our autonomous mode is
We debated back and forth what the term incidental contact listed in the rules means, and figuring out how much weight could be put on the wall of the lander. This needs to be put on the Q&A forum so the game design committee can give us more info and specifics on what exactly this means. While the servo we used for deploying was working great, we couldn't figure out how to utilize that same mechanism to latch at the end of the game, so we've been experimenting more with other designs for that part.
So we tried many ideas with this robot, but in the end we ended up scrapping some. One of them was a single axis. We ended up replacing that one with an elevator. The other one was were the rollers. We ended up replacing those with a bucket.